The next unit of concentration that we're going to learn is called molarity. Molarity, moles over liters. This is the formula is molarity equals moles of solute over volume of the solution in liters. We could solve a problem like this. What is the molarity of a solution? This is the volume, and we have 46 grams of potassium chloride. Well, the formula for molarity is equals to moles over volume in liters. We have the volume in liters, but we don't have the moles. We have the grams. For that, we need to find the moles. So we look at the molar mass of potassium from the periodic table, 39.1, chlorine 35.5, so the molar mass of potassium chloride is 74.6 grams per mole. So we have done this before. Let's take 46 grams converted to mole. 1 mole, 74.6 grams. This cancels out, and we have 0.62 mole. The next step is easy. We just have to substitute that in the equation for molarity. Molarity will be the moles, we just calculated, 0.62, over the volume in liters given by the problem. So the molarity of the solution is 1.76 molar. This type of problem that we're doing now is to understand that each one of these can be used as a conversion factor. So we're going to write 2 conversion factors for each one of these solutions. All right, so we're going to start with the first one. We have a solution that is 8.5% mass over mass. So that we could say we have 8.5 grams of sodium hydroxide over 100 grams of solution. A different conversion factor will be flipping this here over here. So we'll have 100 grams of solution over 8.5 grams of sodium hydroxide. Let's do the second one. It's mass over volume. So we could write 4.8 grams of hydrochloric acid over 100 milliliters of solution. A different conversion factor will be 100 milliliters of solution over 4.8 grams of hydrochloric acid. And the last one will be at 3.4 molar sodium hydroxide. So we could say 3.4 mole of sodium hydroxide in 1 liter of solution. And the next conversion factor will be 1 liter of solution over 3.4 moles of sodium hydroxide. So let's solve these 2 problems together. How many grams of sodium chloride are needed to prepare 225 grams of a 10% mass sodium chloride solution? So we're going to use the unit of concentration as a conversion factor. We start 225 grams of solution. That's what the problem is telling you. And we're going to use this as a conversion factor. So we place here grams of solution and here grams of sodium chloride. Based on the percentage, we know that we have 10 grams of sodium chloride over 100 grams of solution. So what we have to do, 225 times 10 divided by 100, the answer is 22.5 grams of sodium hydroxide. So let's do the second one. How many liters of a 2 molar solution are needed to provide with 66.3 grams of sodium chloride? So since we're dealing with molarity, we cannot use grams. The first step will be to convert these grams to moles. For that, we use the molar mass. Sodium is 23, chlorine is 35.5. So we take 23 plus 35.5, that gives us the molar mass of sodium. 1 mole of sodium chloride, 1 mole of sodium chloride equals 58.5 grams. Then we're going to use this as our conversion factor. 2 molar means that we have 2 mole in 1 liter. So we're going to write this as a conversion factor, placing moles in the bottom, liters in the top. Now we do the calculations. This times 1 divided by this times 2. And the answer is 0.58 liters. The next thing that we're going to learn in this chapter is called dilution. Dilution is a process in which the amount of solute remains the same, but the amount of solvent increases. By doing that, we're changing now the concentration of our solution. The amount of solvent increases, the amount of solute doesn't change, and the concentration of our solution is going to be decreasing. For dilution, we use the following formula. Concentration 1 times volume 1 equals concentration 2 times volume 2. We're going to be solving these type of problems. The first thing, we're going to prepare a table where we identify concentration 1 with volume 1, concentration 2 with volume 2, rearrange the dilution equation, and then do the calculation. So we're going to do a couple of problems together. The first one, what volume of 2%? So we're going to grab concentration 1, volume 1, concentration 2, volume 2. So we have a solution that initially here we're given is 14%, and we have 25 milliliters. We have a concentration that is 2%, and we don't know the volume. So we need to find the volume. C1V1 equals C2V2, and we're going to solve for V2. So we divide by C2 here, C2 cancels out. So V2 is equal to C1 V1 over C2. Now we substitute our values, and we have C1 was 14, V1 25 over C2, that is 2. We do the calculations, V2 equals to 175 milliliters. Let's now work on the second problem. What is the molarity of a solution that was prepared? 10 milliliter. So we're going to evaluate the same thing. We go C1 V1 equals C2 V2. So we evaluate C1 V1, C2 V2. C1 is 2.7 molar, V1 is 10 milliliters, C2, we don't know it, and V2 is 60. So now we're going to solve for V2. C1 V1 equals C2 V2. V2 is equal to C1 V1 over C2. Sorry, we're solving for C2. So this is C2, and this is V2. So we substitute, C1 is 2.7, V1 is 10, divided by 60. Do the calculations, and we end up with C2 equals 2.45 molar.